and I'm going to talk about X-rays today. What first comes to mind when you hear the word X-ray? It's usually the broken bone you had when you fell off the bike or snowboarding or something like that, and that black and white contrast picture. But X-rays are actually used in a variety of different diagnostic procedures, not only that type of. But first off, I want to say a couple words about what X-rays actually are. According to Kelly Cavendish from University of Wisconsin, X-rays are a form of electromagnetic radiation, which is basically light waves, except that they are much more energetic than the waves of optical light we are familiar with. So, like on this graph, that's the visible light range that is like just really thin line in here. So X-rays fell behind the beyond the ultraviolet waves, so they have higher energy. So as you move this way, the wavelength increases, but if you move this way, the rays have more energy to this. So this type of radiation is more dangerous than ultraviolet, but they use low amounts of them for the imaging. How I got interested in this about like a year ago, I wanted to make it as a career. So I started volunteering at the Temple Hospital in the radiology department. And it's an interesting field not only for a career, but just to know what it is for a basic life, because fractures and different ligaments problems happen all the time. And I think it would be useful for you to find out something else about it. X-rays are the type of radiation that is widely used in medical diagnostics in a variety of different procedures, most common of which are conventional X-ray imaging, bone mineral density scanning, and CAT scan. So today I'm going to tell you about how X-rays are used in these procedures. For example, skeletal system is scanned by regular X-ray imaging, and then second for measuring bones density and thickness via VID scanning, and third for bones and tissues analysis using CAT scan imaging. So let's start with something we're more familiar with. According to Holland, a member of the British Institution of Radiology, X-rays were discovered in November 1895 by Wilhelm Röntgen. And ever since then they are used for diagnostics, and they haven't changed a lot. Different research was made to enhance the picture resolution and make it more contrast. He actually pictured the first successful picture he got was the image of his wife's hand, and this picture is very well known in the scientific world as the hand with rings, because they're kind of shiny in that picture. Conventional X-rays, I think most of you had this procedure done to you. The tube with producing X-rays placed somewhere targeting the organs, for example, like for your chest, it would be like here, and the plate that enhances the image goes behind the targeted area, and this way the picture is taken. It takes just a couple minutes to do this, and then we have to print out the image, and it gives X-rays penetrate to the soft tissue and give you the image of the bones and ligaments only. These images are low resolution and contrast images, but pretty good to see if there is a fracture or some swelling in the ligament, something like that. While targeting pretty much same target, the VID scanning, though uses different machinery for it. In bone mineral density scanning, the patient would be laid down on the bench, and then similar tube would be used to target. It's usually for the hips. It's kind of a big joint, so they check if everything is okay in this area, and the wrist, just another tissue to check if the problem is in specific location or it's throughout the body. Rather than producing the actual image, VID scan gives a graph that would compare a patient's result to the range that would be normal for that age and the gender, also because numbers are different for males and females. If X-rays cost varies between $100 up to $1,000 compared to a different procedure and the complexity of the area scan. The BMD imaging costs about $100 to $250. Both these imaging procedures use X-rays, but CAT scan takes radiography to another advanced level. According as Cy Verdon and Jeffrey from Johns Hopkins University say, capable of acquiring volumetric multi-sliced images of an open geometry from a single rotation about the patient and without the need for a ring-based gantry, CAT scan provides images of both bones and organs. So how it looks like? There is a bench, the patient would be lays on the bench, and then it's being launched into some kind of donut-shaped thing. It's pretty tall and takes about 1/3 of the body length. So the patient will be positioned according to what body part needs to be scanned, and it has to be inside this donut part, so it doesn't cover that. It's not a whole tube covering the whole body. In this donut, there is an X-ray producing mechanism that would rotate around this donut, and in a single or just couple of rotations, it takes images in two directions. So simultaneously, it would go from front to back, and then from bottom to the top of the body. And there is a panel placed beneath the patient as well to enhance the image quality. Besides giving these slice-by-slice images in these two directions, computer software will also combine them to create a 3D model of both organs and tissues. So for this very detailed picture, though it's medium resolution image, it can give a lot of information about both problems, if they exist in bones and organs, and if there is any fluids, excessive fluids, anything like that. And it also is widely used for cancer diagnosis because it gives multiple picture, like if where the cancer is spreading. As we can see, X-rays are used for multiple procedures. Most common of them are conventional X-rays, then BMD, which is bone mineral density scanning, and also CAT scan, which together provide a variety of different solutions for any problem that may be existing in the patient's body. Hopefully this information will help you be more familiar with information the doctors threw at you and sign you up for. And there were no CAT scanned during the preparation of this